Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try this question yourself, pause the video now. If you got the answer C, give yourself a pat on the back. If you want to see my explanation of how I found the answer, please continue watching. So, a uniform meter rule of weight 2 newtons is pivoted freely at the 70 centimeter mark. The student holds the ruler in a horizontal position and suspends a 5 Newton weight from the 100 centimeter end. What is the magnitude of the resultant moment when the student releases the ruler? Okay, so the first thing we need to do on this is we need to mark on the weight of the ruler, which is 2 newtons. Because it's a uniform ruler, that is going to be in the center of the ruler, acting downwards. So that's going to be 20 centimeters from the pivot point. We could also mark on the distance this 5 newtons is from the pivot point, which is 30 centimeters. Now the mass is going to try to produce a clockwise turning moment, and the weight of the ruler is going to try to produce an anti-clockwise turning moment. The difference between these two turning moments will be the resulting turning moment. So if I first of all look at the clockwise turning moment, which is produced by the mass, that's going to be the weight of the mass, which is 5 newtons, multiplied by the distance from the pivot, which is 30 centimeters, gives me a turning moment of 1.5 Newton meters. The anti-clockwise turning moment, which is produced by the weight of the ruler, is the weight of the ruler multiplied by its distance from the pivot, which is 0.4 Newton meters. The difference between these two values will be the resultant moment, which is 1.1 Newton meters. I hope you found this useful. Please leave a like and a comment below, and I hope you'll watch more in the series.